Hey guys, welcome to your Unit 8 Lesson 5 notes on special factors. By the end of the day, you'll be able to recognize both the patterns of perfect square trinomials and also difference of squares. So remember when we were looking at factors and we said, hey, you know what? What happens if we have some number A plus some number B and we multiply that by itself? What pattern does that come out to? And we used FOIL to do first, which is A squared, outside, which is A times B, inside, which is B times A, which is the same thing as A times B, and last, and that's B squared. And then we added those all up to get A squared plus 2AB plus B squared. Well, we're going to do that but backwards today. We're going to be looking for numbers that take that same shape, that take that same form, and we're going to figure out what their factors are from there. For example, let's look at A right here. Let's look at option A. We'll notice that we've got something squared. Here we've got an x squared, and then in the middle we've got an even number, so this is going to be 2 times something. And then we have another thing squared. Okay, so we check for squares on the outside and an even number on the inside. And we'll say, does that fit? Well, what happens if this is x squared and this is 5 squared? Well, does the inside match that? If we took our outside guys and we have, okay, our first term is x. If our A here is represented by x and our B here is represented by 5, is that equal to x squared plus 2 times x times 5 plus 5 squared? And that does fit this pattern because 2 times x times 5 is the same thing as 10x. Oh, hey, look, we have x squared, just like x squared, plus 10x plus 10x plus 5 squared plus 5 squared. So that tells us that that fits our perfect square pattern. So this is equal to A plus B squared. We need to figure out, okay, what are our A's again? Oh, here we said our A is x, and our B is 5. So if we want to factor this trinomial, we don't have to go through, okay, well, what multiplies to 25 and what adds to 10? Well, that's going to be 5 times 5. I got it. Oh, hey, look, that's the same thing. X plus 5 squared, x plus 5 squared. It's the same thing. So you don't have to go through all those steps. You can just notice that it fits in the pattern. Ta-da! So yeah, you can either write it as the two separate factors like this, or you can say that that's just x plus 5 squared. They're both fine. They're both totally okay. Now let's look here again. Does this fit our same pattern? Well, is our first guy, is he a perfect square? He is, because 2x times 2x, which is 2x squared, by itself, multiplied by itself, that's equal to 2 times 2, which is 4, times x, which is x squared. And this last guy, is he equal to something squared? Yeah, well, 1 times 1, that's equal to 1. So that's 1 squared. And now we have something in the middle. This needs to be equal to 2 times something. And that is equal to 2 times something. It's equal to 2 times negative 2x times 1. So we're saying, hey, does this fit our pattern of a squared plus 2ab plus b squared? And it does fit that pattern. Here, our a is 2x because 4x squared is equal to 2x squared. So every time we have a, we can write 2x. And here, our b is 1 because that's 1 squared. So, oh, I miswrote this. This is 2x quantity squared. And this is 1 squared. So everywhere we have a b, we can represent that with a 1. So here we go. We've got 2x squared plus 2 times 2x times 1 plus 1 squared. Hey, that fits our pattern. Awesome. So I wrote this stuff down here. So because we know that that follows this pattern right here, know that that's equal to a plus b squared. Here we said our a is 2x and our b is 1. So this is equal to 2x plus 1 squared. Now if these steps are confusing and you want to say, hey, you know what? I don't want to use all that. I don't get it. That's fine. You can totally just go back into your square and say, all right, I need to figure out how to get 4x squared and how to get 1 here. Well, there's only one way to multiply to, oh, and this needs to be negative 4x in here. You can totally follow this pattern if that makes your life easier. You can say, well, there's only one way to get to 1. That's 1 times 1. So the question is, do I need to do 4x times x, or do I need to do 2x times x? And the question is neither, because that will get you to 2x plus 2x, but it needs to be negative 2x, negative 2x. So these need to be negative 2, which gives you your factors of negative 2x plus 1 times negative 2x plus 1, which means earlier we did this wrong. Or, the thing is, I knew it was coming, and I still did it wrong. Because yes, 4x is 2x squared, but it's also negative 2x squared, and that's how we get the negative part. We didn't get the negative part to match up, so this needs to be negative 2x, negative 2, negative 2, negative 2. So there you go. It's negative 2x plus 1 squared, which is negative 2x plus 1 times negative 2x plus 1. Ta-da! Cool. Well, let's say you have a square that's equal, whose area is equal to this, and you need to figure out what its perimeter is. Well, you need to figure out what are the sides of the square. So you can go through and you can figure out, okay, how am I going to get this to x squared plus 18x plus 81, and fill it in here. And that's fine if you want. If you know you need, some way to multiply to 81 and add up to 18, you can do that. That's great. Or you can recognize, oh, this is the perfect square pattern. Whoa, because x squared is x squared. Just need to figure out what. So it's 2 times. We already know our a is x, and 81 is 9 squared. So that tells us our b is going to be 9. Oh, guys, check it out, check it out, check it out. That's equal to x squared plus 18x plus 81. So that works. But remember, a squared plus 2ab plus b squared equals a plus b squared. Now that we know our a and we know our b, we can just substitute what a and b are. Remember, a is x and b is 9. So we know the sides of our triangle, and by triangle I mean square, are going to be x plus 9 and x plus 9. And that makes sense because these will be 9x and this will be 9x, and then that adds up to our original trinomial. Cool, so that worked, yay. But the question said, hey, what's the perimeter? And to get the perimeter of a square, we need to add up all the sides. So we need to take x plus 9 plus x plus 9 plus x plus 9 plus x. How many sides does a square have again? 4. So we need to take that x plus 9 plus itself 4 times. You can add it to itself 4 times. I'm just going to multiply by 4 because I don't want to do all those additions. After distributing, we get 4x plus 36. And there you have it. There's our perimeter. So that's problem solving for you. There's one more pattern that we have. Remember the perfect square shortcut that instead of foiling out all of this, you really don't have to, because this will always come out to be whatever your first guy is. Square him. And then whatever your second guy is, you guessed it, square him too, and subtract. So, if you ever notice you have difference of squares, I'm going to rename this difference of squares. Shortcut looks like this. Hey, look, we have a perfect square. X squared is equal to 5 squared. And 25, nope, I got ahead of myself. I'm sorry. X squared is equal to x squared. 25 is equal to 5 squared. Oh, nice. So in following that pattern, if we ever have a plus b times a minus b, that's going to be equal to a squared minus b squared. Well, check it out. Nice. I'm gonna rearrange these. Is that okay? I'm gonna put them on this side of the equal sign so that they line up. Okay, here our a term is now x, so everywhere we have a we're gonna replace it with an x. And everywhere we have a b, we're gonna replace them with 5. So to factor this, we have x plus 5 times x minus 5. Isn't that so fun? That's so fun. Okay, now let's do one without the shortcut. Ooh. Oh, this is a hard one. Shoot, I should have done the first one without a shortcut. Oh, well. Okay, so we know we've got this square, and we need this area to add up to, oh no, we can, I got ahead of myself. We have a GCF to factor out. Look, they're both divisible by 3. Let's make our life a little bit easier. So if we pull a 3 out, that's equal to x squared minus 16. Oh, now let's just factor x squared minus 16. Well, in here we want to get an x squared, and in here we want to get a minus 16. But we don't have anything to go in here. So these need to be 0. So the question is, we need opposite numbers. We need opposite numbers that multiply to negative 16. That'll be negative 4 and positive 4, because they're opposites, so they add up to 0. And then on our outside, we know, well, x squared is x times x. So to factor, we've got x plus 4 and x minus 4. Yay! So this is equal to 3 times x plus 4 times x minus 4. And you'll notice that that fits into our pattern here. Oh, I took an extra parenthesis. Sorry, man. Okay, where here our x was a, and our b was 4. So we had x squared minus 4 squared is x plus 4 times x minus 4. But since we factored out a 3 at the beginning, we have to hang on to him. So the whole factored form is that guy right there. Sweet. Let's continue to make our lives easier by following this It doesn't follow the pattern, you guys. Yes, x squared is x squared. And yes, 100 squared, I'm not 100 squared. 100 is 10 squared, but we don't have a minus in between. So we can't use our pattern. It doesn't follow this pattern. We cannot factor it. It cannot be factored. Therefore, it's prime. It has no solution if we set it equal to 0, but we'll get to that next unit. Excuse me. Oh, we didn't put the correct answer in our box. Correct answer in box. Factored form. There you go. Okay, here we go. Does this fit into our difference of squares formula shortcut pattern thing? Let's find out. Okay, 4x squared. Is that something squared? Well, 4 is 2 squared, and x squared is x squared. So this is 2x squared. And 1 is 1 squared. Yay, so that tells us that our a here is 2x and our b here is 1. So we're going to take a plus b times a minus b, filling it in, a plus b times a minus b, and the factored form of that is 2x squared plus 1 times 2x squared minus 1. And that's it, we are all set. Like you saw up here, if you want to use the box thing, that's great. You can totally do that. But I'm trying to make your lives easier by noticing a shortcut. So you can use the difference of squares shortcut, which has the minusy guy. Or you can use, just depending on the problem, you can use the sum of squares shortcut as well. Yay, have a fantastic time on your homework.